Good morning, class. So I already covered chapter 4. So let's continue with chapter 5, which is comparative study of NoSQL. These are the content for this chapter 5, technical comparison. So we plan to compare a bit with like relational database with NoSQL. Implementation like engine type, speed, features, limits. So by end of this lecture, students will able to understand the differences between relational and NoSQL database, identify the four types of NoSQL databases, recognize how the implementation languages affect the database performance. This database performance is not only for NoSQL, it's also applicable for relational database. If you are learning about advanced SQL, so you will know about database performance. Next, differentiate between in-memory, disk-based, and hybrid engine. Next, compare the speed and the scalability. List the key features of NoSQL, explain the limitations, and then apply NoSQL concept into real-world scenarios. Let's go with 5.1, technical comparison. First, let's break down the technical differences between NoSQL database and relational database. Relational database is known as RDBMS, relational database management system. So it's used structured tables with rows and columns, reinforce strict schemas. So the schemas, you know, right? We have like entity relationship diagram, which consists of foreign key and primary key. In order to connect each table to one to another to create the relationship. So it's rely on SQL for querying and best for structured data with well-defined relationship. So basically it's very based on, it's totally based on schema that we have prepared. On the other side, NoSQL database store the data in flexible formats like key value pairs. Already teach you during our practical times also. There is a key and there is a value. Documents, white column stores or graphs. So it's a schemaless or the schema is flexible one. Okay, there's no any particular schema that you need to follow like relational database. We have a primary key, we have a foreign key, we have entity and attributes, the same entity and the same attributes for each columns, each rows, each data and everything. We don't have that in NoSQL. And it's optimized for high scalability and performance with large data sets. And basically it's ideal for unstructured or semi-structured data, because unstructured data is there's no any particular format for this unstructured data. So that's very useful to use NoSQL. Types of NoSQL, we already come across all these. These are the four major categories of NoSQL database. We have a key value stores, document stores, white column stores, graph database. Okay, and each type serves different use cases, so choosing the right one depends on your project requirement. But basically we will be using for MongoDB based on document stores. Implementation language. Now let's talk about the programming language used to build NoSQL database and why does this matter. The implementation language affects performance, community support, and ease of integration. Example, MongoDB is written in C++ for core functionality and JavaScript for query language. Cassandra, primarily written in Java, and this makes it easy to integrate with JVM-based application. Redis is implemented in C, Neo4j. It's built using Java and Scala, leveraging the JVM ecosystem again. And then understanding the underlying language can help you to troubleshoot the issue. Why we need to know the implementation language of each of the a NoSQL database that we will be using. It's actually helping you to troubleshoot if there is any issue in future while you're doing any projects, assignments, and anything. Engine types. Okay, there are three types of engine types here. The first one is in-memory engine. Its example is Redis and Memcache. If you learn about computer organization, you know what is cache memory. Cache memory is we have a cache memory in every laptop, computers, workstations. They acting as a temporary storage in order to get retrieve when the user requests for something, some documents. So it try to help the user to retrieve the information in a more faster way. So it's increased the performance. So data is stored directly in RAM, making read or write operations lightning fast and best for caching, real analytics, and session management. Second is disk-based engine. For example, is more on MongoDB and Cassandra. So the data is stored on a disk but optimized for quick access as well. Okay, it's suitable for persistent storage and large scale applications because the data set is unstructured data. Third one, hybrid engine. It's combined in-memory and disk-based approaches for balanced performance. Example is Apache Ignite. It's choosing an engine type depends on whether you prioritize speed or the durability. So it depends on if you're looking for a speed one, then you have to go for either you can go for memory engine or hybrid engine. Or if you want go for durability, then you can go for disk-based engine. Okay, it depends on your project type. 5.4 speed. One of the biggest selling point of NoSQL database is their speed, especially when dealing with massive data set. We actually come to the NoSQL. The reason, one of the main reason or key reason for this is actually to handle the massive amount of data set, which are unstructured data. Okay, here are how different NoSQL databases performs. For example, factors affecting the speed. The data model. Okay, we already learned about data model as well. Key value stores are faster than the document or graph databases because they involve simpler lookups. Okay, compared to the other two, key value is more faster. Concurrency. So simultaneously, it's like handling the process. Some databases like Redis handle thousands of concurrent requests without breaking a sweat. Okay, without breaking the process. So at the same time, okay, for example, like 10.1 second, 10.1 second. So both of these processes actually occurs at the same time. Sharding and replication. Its distributed database like Cassandra achieve high throughput by spreading the data across multiple nodes. So we know that nodes and edges. Next is real-world benchmarks. Redis handles over 100,000 operations per second, making it ideal for caching. Cassandra achieved consistent performance even under heavy loads, thanks to its distributed architecture. Next is MongoDB, slower than the Redis, but offers impressive speed for complex queries. So that is what we are using for our project. Remember, speed isn't everything. Again, it must be balanced with consistency, availability, and fault tolerance. What does it mean by fault tolerance? It tries to give minimal errors. Okay, it tries to avoid the maximum errors that occurs in your process of the project, in completion of your project, development of the database. Next, 5.5, the features. NoSQL databases come packed with unique features tailored to specific use cases. Let's highlight some of the standout features. There are 5 here. First one, scalability. Most NoSQL databases are designed to scale horizontally, adding more machines, unlike a relational database that scale vertically, upgrading the hardware. So this is a difference between NoSQL and relational database. One is adding more machine, one is upgrading hardware. Second is flexibility. It's schema-less design, as we know that earlier, allows you to store diverse data format without predefined structure. When it's come to structured data and we are dealing with relational database, we already have a certain format. You have to follow that particular schema in the format. But in NoSQL, you don't have to follow that. High availability. Number 3, system like Cassandra and Couchbase provide built-in replication and failover mechanism. And number 5, querying capability. While NoSQL doesn't use SQL, many offer powerful query language like MongoDB query language. Neo4j has Kuiper for graph traversal. Number 5, integration. Many NoSQL databases integrate seamlessly with modern frameworks and cloud platforms. Okay, so for that particular query part, we actually using MongoDB. Even in your project also you have to do queries, it's known as MQL, not SQL. So many NoSQL database integrate seamlessly with this modern framework. So these features make NoSQL database versatile tools for handling today's dynamic data needs, because data comes in a different format, different types, different categories, and massive amounts of data. For that, we need this kind of features in order to help to deal with that kind of data. Number 6, 5.6, limits. Despite their advantages, NoSQL database aren't perfect. So let's discuss some of their limitations. A lack of standardization, like unlike SQL, there's no universal query language for NoSQL. Number 2, eventual consistency. Many NoSQL databases prioritize availability over strong consistency, meaning data may not always be up to date. Okay, they are not up to date. Number 3, limited transaction support. A SIG transaction, atomicity, consistency, isolation, and durability are often sacrificed for performance. And number 4, learning curve. Switching from SQL to NoSQL requires learning new paradigms and query language. Okay, SQL is slightly different. SQL is more different compared to MQL. Number 5, tooling ecosystem. Compared to relational databases, NoSQL tools for monitoring, backup, and reporting are less mature. Understanding these trade-offs will help you to decide when to use NoSQL and when to stick with relational database. So for that, which one you want to choose, either relational database or you want to go for NoSQL. So you need to know all these things. Okay, their limitations, their features. Okay, so that then only you can finalize which one that you want to use. So as a summary, to wrap up things, here what we have covered today. So we covered on technical comparisons. Okay, NoSQL database excel at handling unstructured data. Implementation language, the choice of programming language impacts performance and integration. You need to know about the implementation language, so that in future if you got any issues or you want to solve the issue, so you need to know that particular programming language. The engine types, there are 3: in-memory, disk-based, and hybrid. Hybrid is actually combination of in-memory and disk-based. Speed, this features, and the limits. So that's all about chapter 5. Before end up, I will share an activity or a kind of assessment in author, so you guys refer, go through this video chapter 5, and then answer the question and submit the answer in author. Thank you.